Yo! In Lesson 1 of Module 2.4, we're going to talk about solving multi-step inequalities. Woohoo! So, when you're solving multi-step inequalities, the first thing you're going to do is, if necessary, you're going to simplify each side of the inequality. So that would look like this. Here on the left side of this inequality, we have like terms. So we would combine those. X plus 2 more x's is 3x's. So 3x plus 3 is greater than, and I can simplify 7 minus 5. 7 minus 5 is 2. So there's an example of the first thing you do. If necessary, simplify each side of the inequality. If it's not necessary, then it'll look like something like this. See how there's nothing on the left side that I can simplify? Because there's not like terms. And there's nothing on the right side for me to simplify either. So, in this case, it wouldn't be necessary to simplify each side. So after we've made any necessary simplifications on each side of the inequality, the next step is to use inverse operations to undo any operations on the variable. And let's remember that we undo addition and subtraction before we undo multiplication and division. Here's what I mean by that. Take a look at this inequality. Here's my variable. Now, what are the operations on that variable? I have multiplication by 3 and subtraction by 5. I am going to undo the subtraction before I undo the multiplication. Because if I try to undo the multiplication first by dividing by 3, I would have to divide both sides by 3, which is going to give me some fractions. And most people I talk to would rather avoid them. So, to avoid them, we can undo the addition and subtraction before we undo multiplication and division. So to undo a minus 5, the inverse operation of subtraction is addition. So I'm going to add 5 to the left side, and I'm going to add 5 to the right side so that my inequality stays true. So then I get 3x, and then minus 5 plus 5 is 0, so plus 0, which you don't have to write, because 3x plus 0 is just 3x, greater than 4 plus 5, 9er. Then I would undo the multiplication using division. Divide both sides by 3, and I get x is greater than or equal to 3. That's what I mean by undoing addition and subtraction before you try to undo multiplication and division. So then our next step is, when we're undoing that multiplication and division, if the thing we divide or multiply by, the number, is negative, we have to remember to reverse the inequality symbol. So for example, if I had this inequality and I was going to undo this multiplication, multiplying x by negative 2, I would divide both sides by negative 2, because that's the inverse operation of multiplying by negative 2. Negative divided by negative is positive, 2 divided by 2 is 1, so that just gives me x. 8 divided by negative 2 is negative 4, but because I divided by a negative, I have to reverse the inequality symbol, so it becomes less than or equal to. So those are the main steps to remember when solving multi-step inequalities. Example, shall we? Alright, so first thing I'm going to do is simplify each side of the inequality if necessary. On the left side, I don't have any like terms to combine. And on the right side, there's nothing to simplify, so that is not necessary. Next, I'm going to use inverse operations to undo any operations on the variable, keeping in mind to undo addition and subtraction before multiplication and division. So I'm going to undo this addition. It's got a plus 7, so I'm going to do a minus 7. So my less than stays. 9 minus 7 is 2, and 7 and negative 7 is 0, so I got y divided by negative 6 is less than 2. So my next step is what? Done. to remember that when I am multiplying or dividing by a negative number, I got to remember to reverse the inequality symbol. Now, over here I got y divided by negative 6. And the opposite of dividing by negative 6, or the inverse operation of dividing by negative 6, is multiplying by negative 6. And since I'm multiplying by a negative number, I have to switch the inequality sign. So, negative 6 divided by negative 6 is 1, so I just get y over here. 2 times negative 6 is negative 12, so I get y is greater than negative 12. And now I need to graph that. So I'll say, all right, well, let's say this is negative 12, negative 11, negative 10, negative 9, negative 8, and whatnot. And then greater than negative 12. So my border point is this negative 12. It's just greater than, it's not greater than or equal to, so I'm going to leave an empty circle. And then greater than is the values that are to the right. So that's the graph. Here's the solution, and then there's the graph. Woohoo! How about one more? So, step 1, simplify each side. Oh, I do have some like terms over here that I can combine. V plus 3 more V's is 4V. So 4V minus 4 greater than or equal to 8. Next, use inverse operations to undo stuff. Addition and subtraction before multiplication and division. So I'm going to undo the minus 4 before I try to undo the times 4. The opposite, or inverse, operation of minus 4 is plus 4. So I'm going to plus 4. I'm going to add 4 to both sides of this inequality. So I get 4V is greater than or equal to 12. Alright, so I need to undo this multiplication also, keeping in mind that if I have to multiply or divide by a negative number, I have to reverse the inequality sign. What I have here is V times 4. So the opposite of times 4 is dividing by 4. So I end up getting V greater than or equal to 12 divided by 4 is 3. And since the 4 I'm dividing by is positive, I don't have to change the inequality sign. So there is my solution written as an inequality. And now I'm going to graph that. So I want the numbers that are greater than or equal to 3. Well, here's 3. Greater than is to the right. And equal to, we show by filling in that circle, showing that it can equal 3, or 3 is a solution to this inequality. So boom shakalaka, now it's time to practice. Enjoy yourself. Have a great day. You're an awesome person. You deserve a treat. You should have a treat or a prize. Yeah, a treat or a prize. You decide.